This is section 12.3, dividing polynomials. And this is the simplification method, not long division. Okay, so when you're dividing by a monomial, remember that means one term, you're just going to divide each term by the monomial. So one way to think about it is to rewrite this as 8x divided by 4 minus 16 divided by 4. And 8x divided by 4 leaves you with 2x, and 16 divided by 4 becomes minus 4. Number 2, 3x goes into 9x squared and 27x. And you're left with 3x and 9. So remember, division is the opposite of multiplication. So if you wanted to make sure that you did it correctly, you could always multiply through again to make sure. 3x times 3x is 9x squared. 3x times 9 becomes minus 27x. Okay, example 3. You're still dividing a polynomial by a monomial. So just go through each one and divide by 2x. And you're left with 2x squared plus 4x plus 5. So don't forget, when you have the exponents, it's kind of like crossing out. So you have 3 on the top, 1 on the bottom, you lose 1, you're left with 2. Same thing here. 1 crosses, you're left with 1, and both cross out. And again, I could multiply through by 2x to make sure that I divided correctly. Okay, so we can also divide a polynomial by a binomial. So remember, that means it has 2 terms. In these examples, there's no remainder, so they are going to work out nicely. So this is technically just simplification. If you have a polynomial like x squared plus 2x minus 3, and you're dividing by x minus 1, what you need to do is factor the polynomial so that you can see if it's going to cancel. So remember, x squared plus 2x minus 3, I'm looking for factors of negative 3 that when added together give you 2. So I get positive 3 and negative 1, so that becomes x plus 3 x minus 1, and then I'm dividing by x minus 1. Now remember, things can only cancel when they're being multiplied, so it will work in this case even though there's addition and subtraction, because it's the whole thing, these two sets of parentheses being multiplied. And because of that, I am allowed to cancel x minus 1 and x minus 1. So I'm left with x plus 3. So again, you could multiply them back out, x plus 3 times x minus 1, to see that you do get the original polynomial that you were dividing into. Okay, and for the last example, again, we have a polynomial divided by a monomial, and you are going to be able to simplify, but this time you're going to have to do slide and divide. So the 2 goes to the 3, becomes x squared plus 5x minus 6. Factors of negative 6 that when added together give you positive 5 would be positive 6 and negative 1. So x plus 6, x minus 1. Don't forget to go back and divide by 2, slide and divide. So you get x plus 3 times 2x minus 1. Okay, so then I'm going to rewrite that polynomial in the factored form, and I get x plus 3, 2x minus 1, divided by 2x minus 1, and then 2x minus 1 will cancel because they're being multiplied. So 2x squared plus 5x minus 3 divided by 2x minus 1 leaves you with x plus 3. And again, you can multiply that back out to make sure that you get the original polynomial that you were dividing into. Keep in mind that if you have multiple choice, one way to do it is to go through and multiply the thing that you're dividing into the polynomial and the options for what's left, and see if you can multiply which one gives you the polynomial. So that's another kind of way to go about this. If you are doing something that doesn't divide evenly and you end up with a remainder, you're going to have to use long division. That's something different. So for this method, when you have a polynomial that's factorable, you're just going to factor and then simplify. And that's it for this section.